Hello everybody, the title of my communication is Synthesis and Characterization of Diatomites Reported TIFE Nanoparticles for Optical Properties. Work plan, introduction, objectives, materials and experimental methods, characterization of aluminum silicate materials, photodegradation of V.3 endotrend textile dye by diatomite modified by ferrihydrite with UV process, and finally conclusion and prospect. The main phases of ferric oxide in nature in ascending order of crystallinity are ferrihydrite, magimite, lepidocrosite, hematite, and goethite. Ferrihydrite is a less crystalline brown iron oxide with a large surface area. An alternative to granular ferric hydroxide adsorbents among these materials is diatomite, which is a soft light rock composite of amorphous silica microfossils of aquatic. These materials are prepared by precipitation of the iron tree salt under alkaline conditions. There are several methods to modify the characteristics of diatomite surface. Among these methods, the purification of diatomite by acid chlorhydric, calcination of diatomite, manganese modified diatomite by the alkaline treatment with soda and manganese chloride. Synthetic dyes are increasingly used in the textile and industrial dyeing. Some dyes are carcinogenic and mutagenic. In addition, many treatment systems have been proposed for the removal of synthetic dyes from aqueous solution by coagulation, flocculation, and photocatalytic degradation. But dyes such as endothelin or indigo are partially insoluble in water. Photocatalytic oxidation process a wide range of persistent organic pollutants such as aromatic hydrocarbons, derivatives, furfural alkanes, dyes, etc. Heterogeneous photocatalysis by titanium oxide is still limited, whereas doping with metal species such as vanadium, chromium, tungsten, and iron has been studied for improved photocatalytic performance under visible light irradiation. In our case, the catalyst is a diatomite modified by iron. Photodegradation of textile dye V.3 endotrend by heterogeneous photocatalysis, light source UV lamp plus co-adsorbent activated diatomite modified by iron, depending on the pH of the medium and irradiation. The gap energy of titanium oxide diatomite as 3.2 electron volt and catalyst oxide of iron modified diatomite in the range between 1.6 and 2.7 electron. Materials and experimentals. The diatomites. Diatomites are very light, very porous siliceous rocks formed mainly by the accumulation of opal fossils of diatoms. Diatoms are unicellular microorganisms generally between 10 and 15 microns in size, characterized in that they are the only unicellular organisms to have a siliceous outer structure completely enveloping the transparent and rigid cell appointed. There are two types of diatoms, centric diatoms and pinnate diatoms. Origin of Raw Diatomite of Sig. The diatomite used in this study comes from the region of Sig, 50 km from the city of Oran in the west of Algeria. It is in the form of a white powder. After grinding with a mortar and a gate pestle and strainer sieving, the particle size of the fraction is between 0.4 and 0.6. The choice of these materials was dictated by the fact that it is very abundant. It has an adsorptive affinity towards heavy metals and organic molecules. Application area: purification of drinking water, adsorbent pesticides, construction and thermal insulation, chromatographic and catalytic supports, abrasive products, etc. Preparation of diatomite modified by we take 45 gram of raw diatomite plus 0.5 gram of titanium oxide. Then we add sodium hydroxide with 6 molar concentration. We make a string at 90 Celsius degrees for 2 hours to partially dissolved silicon. Then we add the ferrous chloride tetrahydrite with concentration 1 molar. then stirring and oxidation at room temperature for 24 hours, centrifugation for 20 minutes to remove the supernatant, watch with distilled water, oxidation by air for 24 hours to continue the removal of excess of soda and oxidation of iron to hydroxide, centrifugation for 20 minutes to remove the supernatant, drying at 105 Celsius degrees in an oven for 24 hours. We obtain diatomite modified by ferrihydrite and make the characterization. Preparation of diatomite modified by ferrihydrite with calcination at 600 Celsius degrees. We take diatomite modified by ferrihydrite, then calcination at 600 Celsius degrees in a tubular oven, and speed rate of 1 Celsius degrees per minute during 24 hours. We obtain diatomite modified by ferrihydrite with calcination at 600 Celsius degrees, and we make characterization of aluminosilicate. Quantitative mineralogical analysis by X-ray fluorescence. Wetherland Sig Raw Diatomite showed the dominance for oxides as silica, iron trioxide, alumina, and calcium oxide. And for diatomite modified by ferrihydrite with calcination at 600 Celsius degrees, shows dominance for oxides as silica, iron trioxide, sodium oxide, and alumina. Analysis by X-rays. For raw diatomite of Sig, there are many phases as quartz, albite, iolite, nonotronite, muscovite, plagioclase, opal A, smectite, colonite, montmorillonite, feldspar, calcite, lepidocrosite, dolomite, diopside, rutile, and aragonite. For diatomite modified by ferrihydrite with calcination at 600 Celsius degrees, there are many phases as iolite, akaganite, opal A, kaolonite, lepidocrosite, quartz, halite, ferrihydrite 6 lines, ferrihydrite, rutile, calcite, alminite, suezmonite, onstatite, ferroxide, magimite, hematite, and anatite. For Fourier transform infrared and the absorption band CO from carbonate and the absorption bound COH from silanol groups and LOSI from saline group and SaOSe from siloxane. For diatomite modified ferrihydrite with calcination at 600 Celsius degrees, there are many absorption bands as the FH interaction between water sorbate and iron diatomite modified, and new absorption band from sinyl group, the absorption band of many iron phases as magimite, schwarzmannite, lepidocrosite, iron hydroxide, iron hydroxide, akaganite, hematite, and goethite, and ferrihydrite, and the absorption band SAO from siloxane group. Morphological characterization by scanning electron microscope. For raw diatomite of Sig, there are two types of particles: contact particles with the diameter between 0.09 and 0.5 micrometer, and the pinnate particles with the length between 2.5 and 3.5 micrometer. For diatomite modified by ferrihydrite with calcination at 600 degrees, there are two types of particles: pinnate particles with the length between 3.3 and 15 micrometer, and the width between 1.6 and 7.6 micrometer, and the centric particles with the diameter between 1.6 and 8 micrometer. For thermal analysis, for raw diatomite, there are two phases of thermogram analysis. For the first phase with loss mass 0.75%, departure of physiosorbate water, dehydration, and the second with the range between 50 and 200 degrees, and the second phase between 200 degrees and 1.7 degrees with loss mass as 2.5%. Decomposition of the organic phases present on the silica surface, the hydroxylation of selenol groups during temperature rise. And for diatomite modified by ferrihydrite with calcination at 600 degrees, there are two phases in the range 50 to 1200 degrees. For the first phase between 50 and 260 degrees with loss mass 1.77%, departure of phases for water dehydration, and the second phase between 200 degrees and 100 Celsius, 1200 Celsius degrees, decompose with the mass with loss mass as 37.51%, decomposition of the organic phases and optionally to the hydroxylation of selenol groups present in the surface silica of diatomite modified by ferrihydrite during the temperature rise with two endothermic peak. The first endothermic in the temperature 795.28 with enthalpy 156.2 joule per gram, and the second endothermic peak in the temperature 1027.17 degrees with enthalpy 465.4 joule per gram. For surface charge, the pH of .0 charge as 6 by potentiometric titration method. UV-visible use the diffuse reflectance spectroscopy. Use TOC methods. The max of wavelength as 238 nanometer with the gap energy 1.16 electron volt. For the degradation of Photogreen 03 indutron with presence of diatomite modified by ferrihydrite with calcination, use UV radiation. The pollutant study Photogreen 03 indutron in the textile industry in the Senia in Oran. With molecular structure, with pH of solution as 6.9 and solubility alkaline medium. Molecular formula C13 H15 NO2. Test photodegradation of photocatalytic activation. Use UV lamp with wavelength 365 nanometer. We take 200 milliliter of Photogreen 03 into textile dye with concentration 20 milligram per liter with the 3 medium of pH as 4, 7, and 10, and we take 0.5 gram of diatomite modified by ferrihydrite with calcination at 600 degrees. And photodegradation of Photogreen 03 into terrain in presence of diatomite modified by ferrihydrite with calcination at 600 degrees with UV irradiation. The kinetic of photodecolorization and order kinetic of photodecolorization and decolorization removed with the best result at pH pH equal 4. Figure test photodegradation photocatalytic activity of Photogreen 03 in Dotran in presence of diatomite modified by ferrihydrite with calcination using UV irradiation with disappearance of solution. Conclusion: the cold adsorbent of diatomite modified by ferrihydrite with calcination at 600 degrees gives a better rate of discoloration, approximately 97%. Thus, the use of catalyst DMF1X6 for the degradation of Photogreen 03 in total textile dye under the UV lamp is an economically efficient method compared to titanium dioxide, allowing for the latter is more expensive. For specs, for the final results obtained, some perspectives have been proposed which are initiate different methods of analysis of prepared diatomite, magnetization, atomic force microscopy, X-ray photoelectron spectroscopy, X-ray near edge absorption spectroscopy, XNS, Brunette image Taylor, BUT, and transmission electron microscopy, TE. Measures iron content by atomic absorption spectroscopy. Make a synthesis of several mixture, diatomite plus cement, diatomite zeolite, or the doping of diatomite by manganese with manganese 2-chlorine, diatomite manganese to increase the specific surface and the porosity. Initiate different methods of analysis of prepared diatomites and its precipitates after the photocatalytic reaction. Fourier infrared and nuclear magnetic resonance measures all organic materials in the dye and their exteriorize to determine the pollution parameters, COD, chemical organic demand, biochemical organic demand, and total organic carbon before and after the photocatalytic reaction, photomineralization, to identify and know the byproducts by gas chromatography, mass spectroscopy, and nuclear magnetic resonance. And thank you for your attention.